Dear students, welcome to Elate Classes. Today we are going to discuss velocity time graph and its physical significance. Please watch the video on position time graph before watching this video. Students who want to join our offline classes for board or competitive exam preparation, they can contact us in our contact numbers. The contact numbers will be available in the description of this video. Thank you for watching. Okay, now let us start velocity time graph and its physical significance. Velocity time graph represents how velocity of an object changes with time when the object is in motion. So, VT graph represents how velocity varies with time when an object is in motion. Now, what is the physical significance of VT graph? The physical significance of VT graph is the slope of VT graphs give us acceleration of the object when it is in motion. Another physical significance of VT graph is area under the VT graph gives us displacement of the object during its motion. Let us now discuss area under the VT graph. In this graph, V versus T is plotted for uniform acceleration motion, and in this graph, velocity versus time is plotted for non-uniform acceleration motion. Let us now see why this is for uniform acceleration. Uniform acceleration means acceleration is constant. Now this VT graph is represented as a straight line. Now we know straight line has constant slope. So at every time instance, the slope will be same. Since slope is same, and from the first physical significance of VT graph we already know slope of VT graph gives us acceleration. So we know when the VT graph is a straight line with inclined position, this graph will give us uniform acceleration motion plot. Now look at this second graph. In this VT graph, the graph is a curved line. Now again, the slope of the VT graph will give us acceleration. So if I draw tangent at different positions on this graph, at different time instance, basically we are getting different slopes of the tangent. Since slopes are changing, that means velocity at different time instance are changing. That means this graph is representing non-uniform acceleration motion. Let us now see how we can calculate the area under these graphs. Let us now first see for uniform acceleration motion, when the graph is a straight line, what I will do, I will take an elementary strip for a differential amount of time dt. Let us say for this differential change in time, velocity of the object is almost constant. If is so, then we can assume this elementary strip as a rectangular strip. So we know the area of a rectangle is nothing but length into breadth. So if this is the length of the rectangular strip and this is the breadth of the rectangular strip, what I can write? The area of the strip, the differential area dA, I can write as VDT. dA I can write it as VDT. Now we know for instantaneous velocity, v is equal to rate of change of displacement. So from this I can write dx is also equal to vdt. dx is also equal to vdt. So from these two equations, from equation 1 and equation 2, if I integrate on both the sides, for this equation first, equation 2, what I get? I will get net displacement x is equal to integration of vdt. Net displacement x is integration of vdt. And from equation 1 I get, if I integrate on both the sides of equation 1 implies, when I integrate, this will become total area. On the right hand side I will get integration of vdt. Now when I compare these two relations, x is equal to vdt and area is also equal to vdt, that means from these two we can understand the area under this graph will basically give us the displacement. Similarly, from this graph, again I can calculate the area under the VT graph for this graph as well. The process is same. I will again take an elementary strip for a differential amount of time dt. Let us again assume for this differential change in time there is no change in velocity. If there is no change in velocity, then we can assume this elementary strip as a rectangular strip. Again for this strip I can write differential area dA is equal to again vdt. So if I integrate, I will get A is equal to integration vdt. Again, from the relation of instantaneous velocity, I can write v is equal to dx by dt. From here I can write dx is equal to v dt. So when I integrate on both the sides, I will get x is equal to integration of v dt. So basically from these two relations again I can understand that integration of v dt is area under the graph, and that area is nothing but the displacement, net displacement of the object during its motion. Let us now discuss some important VT graphs for constant acceleration motion. I am showing 4 graphs here. All these 4 graphs are for constant acceleration motion. Let us first discuss the graph A. In a graph A, as you can see, velocity is in the first quadrant, that is in the positive velocity quadrant. That means this graph is representing positive velocity. Now from our previous lecture we know when velocity is positive, that is velocity is greater than 0. The meaning is the object is moving in the positive direction. That means direction which is assumed as positive, in the direction object is moving. And then if you see, this is a straight line with certain slope, and we know straight line has constant slope. That means everywhere slope is same. At all time instance slopes same. That means since slope same and slope itself is acceleration in VT graph, that means acceleration is also constant during the entire motion. So this is depicting a constant acceleration motion. Object is moving in the positive direction because velocity is greater than 0, and slope is constant, acceleration is constant, and as you can see from here, time equal to 0, this is t equal to 0. With increase in time, velocity is also increasing. That means this graph is constant acceleration motion where the speed of the object is increasing with time. Now let us see the second graph. Again for this graph, velocity is positive because it is in the first quadrant. We know in the first quadrant both the variables are positive, so velocity is positive here as well. Since velocity is positive, that is greater than 0, again this graph is representing a motion where the motion of the object is in the positive direction, first point. And then as you can see, this is again a straight line. So for a straight line, again slope is since constant, that means acceleration again is constant at all time instance. So it is a constant acceleration motion graph. But what is the difference in this graph than this? Here the slope was positive, here the slope is negative. Why slope was positive here? Because the angle with the horizontal was less than 90 degree, and we know slope is tan theta. If theta is less than 90 degree, tan will always be positive. So here it was slope was positive, but here slope is negative. That means since slope gives us acceleration in a VT graph, and for this graph since slope is negative, that means this is representing negative acceleration. So let us now discuss another graph. This is also a constant acceleration motion graph. Why? Again it is a straight line. Since it is a straight line, so slope is constant, That means acceleration is going to be same during its motion. Again in this graph if you see, slope is again negative, because if you see the angle with the x-axis is greater than 90 degree. When we have 10 90 plus theta, that is theta larger than 90 degree, that is theta when it lies between 90 to 180, we get negative slope. So here, although constant acceleration motion, it is a constant acceleration motion, but slope is negative. That means this graph represents negative acceleration as well. But what is the difference in both the graphs? Now we know here this also represents negative acceleration, this also represents negative acceleration. But difference between these two graphs is, here velocity was in the positive quadrant, velocity was positive here. Here velocity is negative. That means in this graph acceleration is negative. Since velocity is negative, that is less than 0, we know from our understanding of velocity in the xt graph, when velocity is negative, we know that the motion is in the negative direction. So here this graph is representing the motion of an object in a negative direction with constant negative acceleration. That means here speed is increasing in the negative direction. Here speed is increasing in the negative direction, but here speed is decreasing, but it is in the positive direction. Now let us see the fourth graph, graph D. This graph D, if you carefully see, it is the combination of graph B and graph C. If you see, from time t is equal to 0 to time t is equal to t1, this part of the graph is similar to graph B, and the remaining graph from t1 to this time, the graph is similar to this graph. That means from time t is equal to 0 to t equal to t1, the object was moving in the positive direction, but at time t1 the object has changed its direction of motion and is moving after t1 in the negative direction. Also, this entire graph is representing negative acceleration. Why? Because this straight line has a negative slope, as the angle made by this straight line with the x-axis is always greater than 90 degree. So these are the four important VT graphs. Let us discuss some important previous year's questions. This question is from JEE Main 2026. Let us solve this question first. The question says, the velocity distance graph is shown in figure. Which of the following graphs represent acceleration versus distance variation for the system? Now this is the given graph. They have given a graph between velocity and distance. In our discussions, we have not studied Vx graph, we studied Vt graph, but there is some trick in this question. they have given the graph between velocity and distance, not velocity and time, and they have asked us to find a graph between acceleration versus distance, and these are some options they have given. These 4 options are there. So let us now solve this question. So if we see this given graph between velocity and distance, we can see that the slope of this Vx graph is negative, and the relation between velocity and distance is a proportional relation. So with this information, let us solve this question. Solution. So as I have already told previously in our discussions, we have studied graph between velocity and time, but this is a graph between velocity and distance. Now let us solve this question. We know acceleration is rate of change of velocity. This is we know from the definition of acceleration, instantaneous acceleration. So this relation I can write like this. Rate of change of velocity with respect to distance into rate of change of distance with respect to time. Now, if it is a rectilinear motion, obviously distance is nothing but displacement. So don't get confused with distance and displacement concept. Although it is mentioned as x as distance, if it is a rectilinear motion problem, obviously displacement is going to be same as distance. So assuming this motion is a rectilinear motion, I can write this dx by dt, rate of change of distance or displacement with respect to time, I can write velocity into dv by dx. Now from the graph we know the slope of this is a straight line, the graph between velocity and distance is a straight line with negative slope. Why negative slope? Because the angle with the x-axis is greater than 90 degree. When angle is greater than 90 degree, tan theta becomes minus cot theta. That means the slope of this straight line is a negative slope. So what we can understand from that is that for the given graph, acceleration is equal to instantaneous velocity into negative constant slope That means anyway slope is a constant value, but slope is negative. Since although it is a negative term, slope is negative, this is a constant. So if I remove this constant, I can find A is proportional to B. That means for the given motion, acceleration is directly proportional to velocity. and also acceleration is equal to velocity, instantaneous velocity, into negative constant slope. So this is the result that we can derive from this graph. Now let us see these options one by one. Now if you see this option A, according to this option, obviously A is changing from negative, here A is negative when x is equal to 0, at some intermediate x acceleration is 0, and then acceleration is positive. As per option B, acceleration at x equal to 0 is negative, and from there negative acceleration is increasing. As per option C, acceleration at x equal to 0 is positive, and with increase in x, acceleration is increasing, that is positive acceleration is increasing. And from the figure D, option D, you can see it is a case of constant acceleration. Now we already have found that acceleration is proportional to velocity. That means our graph is going to be changing just like velocity. That means since velocity is proportional to x, my acceleration is also going to be proportional to x. So we can discard this option. Acceleration is not going to be constant, so we can discard this option. So this option is not going to be my solution. So I am left out with 3 options. Now you see, from this option, if I try to explore this option, at x equal to 0 to x equal to this value, that means for the value of x for which from this figure, let us see first from this figure, for the value of x for which velocity is positive. Now see, from here to here velocity is positive. So for the value of x for which velocity is positive, if velocity is positive, acceleration is equal to velocity is positive into a negative constant value. That means acceleration should be less than 0, because velocity is positive, this is a positive term and this is a negative term. When you multiply positive with negative, my result is going to be a negative term. That means for this region, acceleration should be negative. Now you see, acceleration for this option also negative up to certain x value, but for this figure the entire acceleration is negative. So this also cannot be one of the, this option also is not a correct option, so we can discard this option as well. Now we are left out with these 2 options. Now if you see from this figure again, at this value of x, velocity is 0. So for the value of x for which velocity is 0, what will be my acceleration? If my velocity is 0, acceleration should also be 0. So in this graph, nowhere with x acceleration is becoming 0. That means this option is also a incorrect option. So I am left out with this option and this is the correct option. So now if we again recheck this graph, at this value of x equal to 0, acceleration is 0, because from this graph, from here to here, from x equal to 0 to this value of x, if you see, velocity is positive, it is in the positive quadrant of velocity. So up to this value, velocity is positive. So if velocity is positive, this is negative, acceleration should be negative. That means up to certain x value, my acceleration should come as negative. So this is fulfilling that condition of this given graph. At x equal to this value of x, velocity should be 0. That means when velocity is 0, as per this relation, acceleration should be 0. That means this graph is now crossing this x-axis. That means acceleration here is 0. And beyond that, if you see, after this value of x, my velocity becomes negative. So from this relation, velocity, if velocity is negative, negative into negative, I will get a positive term. That means beyond this, acceleration should come as positive. So beyond this, acceleration is coming as positive. So this is the correct option. Also, since acceleration is proportional to velocity, obviously, since velocity with respect to x is a straight line, acceleration with respect to x is also should be a straight line. So my correct option is option A. This question is from JEE Main 2025. So as per this question, it is say the velocity time graph of an object moving along a straight line is shown in figure. So this is a VT graph which is shown for an object which is moving along a straight line. So they have asked, what is the distance covered by the object between time t is equal to 0 seconds to t equal to 4 seconds. That means from 0 seconds to 4 seconds, whatever distance the object has covered, that distance is to be calculated, right? Okay. So we know from the physical significance of VT graph that area under the VT graph gives us displacement. We know area under the VT graph, area under the VT graph gives us displacement. Now here in the question they have mentioned distance, not displacement, but since motion is a straight line motion, distance and displacements are basically same. So to find the distance, what do we need to calculate? We need to calculate the area under the VT graph. So up to 4 seconds, what will be the total area? So up to 4 seconds, if I see, the graph is basically consists of two geometrical figures. One is this triangle and one is this rectangle. So area of this triangle is half into base into height, plus area of this rectangle is, this is breadth and this is length. So I can write half into 2 into 10, this is for the triangle area, this area, plus 2 into 10. 2 cancel out. So 10 plus 20 is equal to 30 meters. So answer will be 30 meters. Now let me tell you one more thing. Here the entire VT graph is basically representing positive velocity. That is why the area under this graph, total area under this graph is positive displacements. That if I have to find out it is not asked in this question, but if we need to calculate the total displacement also for the entire motion as per this figure, that for the entire motion from 0 seconds to 6 seconds, the entire displacements are positive displacements. So we will only need to calculate the area of this geometrical figure to find out the net displacement up to 6 seconds. But if there is some area which is in the negative side of velocity, we had to subtract that velocity area from our total area so that we can get the net displacements. So, but that is not there in this question. We only need to calculate the distance. So, this is the solution for this question. Okay, let us now solve another question. This question is from JEE Main 2023. So, as per the question, the velocity time graph of a body moving in a straight line is shown in figure. This is a velocity time graph of a moving body which is moving along a straight line. We need to calculate the ratio of displacement to distance traveled by the body in time 0 seconds to 10 seconds. That means from 0 seconds to 10 seconds, whatever displacement and distance covered by the body, I need to calculate the ratio of those displacement to distance. That means, let us solve solution. I need to calculate this ratio, displacement to distance. Now in the previous question I was explaining after the solution, I explained you few points where I told you if the VT graph is on the negative side. Now you see in this figure, in this question, the figure which is given, the graph between V and T. Here velocity is on either side of time axis. That is, this velocity which is above the time axis, which is this area and this area, they are representing basically positive displacement, and this area and this area, it is representing negative displacement. Why? Because here above the time axis velocity is positive, and when velocity is positive we know object is moving in the forward direction. That means those distance which is covered in the forward direction, those distances will be added, and whenever velocity is negative, the meaning is object is moving in the negative direction. That means the object has moved from 0 seconds to 2 seconds in the forward direction. Then from 2 seconds to 4 seconds, it has again returned to a negative x direction. And then again from 4 seconds to 8 seconds, it has again moved in the forward direction. And from 8 seconds to 10 seconds, the object is again returned in the negative x direction. That means the total distance covered is going to be the distances covered in every time interval. Means in 2 seconds, whatever distance is covered, that will be counted. Next 2 seconds also will be counted. Next 4 seconds also will be counted and added. And next 2 seconds, whatever distance is covered, that also will be added. But displacement will be keep on getting reduced every time the object is returning in the negative x direction. That is why the displacement and distance are going to be different, and we need to calculate the ratio between displacement and distance. Now, as I already told you, this area and this area will be contributing to the positive displacement, and this area and this area will be contributing to the negative displacement. So we know from the physical significance of area under the curve, for positive displacement we will add these two areas, and for negative displacements we will add these two areas. So total displacement will be this area, that is 8 into 2, that is 16, 8 into 2, plus this area, that is 4 into 4, not 4, sorry, 4, 4 into this 4, this displacement 4 into 4. These two are plus, then these two will contribute to a negative displacement because velocity is negative. So I will take negative in front of it and I will add these two areas together. This is 4 into 2. This is 2, this is 4. So basically 2 into 4 plus this area, that is 4 into 2 again, that is 2 into 4 again, 2 into 4. These two areas are contributing to a negative displacement and these two areas are contributing to a positive displacement. So net displacement will be this minus this. Since the distance, since it is a scalar quantity, for the entire time 0 to 10 seconds, whatever distance it has covered, that all will be added, whether it is moving in the forward direction or in the negative direction. So these two areas are representing forward motion, these two areas are representing backward motion. Since distance is a scalar quantity, we are going to do scalar addition of all these areas. So basically distance will be 8 into 2 plus 4 into 4 plus 2 into 4 plus 2 into 4. So if we simplify, what we are going to get, 8 into 2 is 16, 4 into 4 is 16, 32. So 32, 2 into 4 is 8, 2 into 4 is 8, 32 minus 8 will be 24. So it will be 24. 8 into 2 is 16, 4 into 4 is 16, 16 plus 16 is 32, 32 plus 8 is 40, 40 plus 8 is 48. So answer will be 1 by 2. That is option will be 1:2. This is the correct answer. The answer is option C. I hope you have understood these problems. Kindly provide your valuable feedbacks in the comment section. And if there is any doubts in these lectures, send your queries in the comment section as well. I'll try to solve. I'll try to give solution to those confusions, those queries. Thank you so much for watching.